In 8.4, we're going to put together what we've done in all of the previous sections along with vertical stretch. And we will look at when we are using a parent function or when we are using points, but we are going to start with parent function. So, as a recap, our rules for going right is to subtract on the inside. To go left, we add on the inside. To go up, we add on the outside. And to go down, we subtract on the outside. That's all of our translations. Then we look at our reflections. To reflect over the x-axis, we have a negative on the outside. And to reflect over the y-axis, we need a negative on the inside attached to the x. Now our new part here is our vertical stretch. And that is going to be the number that we are multiplying by out front. And the way that's going to work is the stretch is always over 1 up however much the stretch is. That's why it's considered our vertical stretch. So over 1 up whatever that stretch value is. So let's see what that looks like. For example A, we will describe how the graph of y equals 0.5 absolute value of x relates to the graph y equals absolute value of x. And then we are going to graph both. So starting with just the comparison between the two, the only difference here is this 0.5 value that's out front, that's not present in the parent function. And that is our stretch value. So instead of going up 1 and over 1 like we do in our parent function, our vertical stretch, we'll be going up 0.5. Then our graph will reflect that. And really, all that means is that all of our y values are going to be cut in half or multiplied by that factor of 0.5. So first, to graph our parent, we start at 0, 0, and we are going at a slope of 1 all the way up in both directions. Our new equation that we said, instead of going up over 1 up 1, it's going to be over 1 up 2, which is going to give us a stretched out version of our parent function. Now looking at example B, we are going to write an equation for this function. So first thing we should always look for is our translation, our moving left, right, up, or down. So our new vertex here is -4, 2, which means we moved left 4 and up 2. Then we also should be looking for any kind of reflection. And since it's opening upwards, we don't have any reflection. And then we look for our stretch. And remember, that is always found by going over 1, and then the stretch is how much you go up. So instead of going over 1 and up 1, we actually go up 1.5. So that's going to be our vertical stretch value. So our equation is y equals 1.5. And then we are going left 4, so we add 4 on the inside, and up 2, we add 2 on the outside. Now it is your turn to go through the guided practice, and when you are ready to check both of your answers, unpause the video. For problem 1, the 3 out front gives us a vertical stretch of factor 3, and this -2 on the outside means we move down 2. So the first thing we do is we plot our starting point, down 2, and then we can use our vertical stretch to plot the second point. So we go over 1 and up 3. And because this is absolute value, we can do the same thing in the opposite direction to give us our new graph. For example 2, we have a parabola as our parent function. We have a negative out front, which gives us a reflection over the x-axis. 0.5 is our vertical stretch. -4 on the inside moves right, and +3 on the outside moves up. So first thing we need to do is plot our first point at 4, 3, and then we can plot the second points by following our reflection and stretch. So we go over 1, down a half. And we can do the same thing on the other side since it is a parabola to get our shape of our new function.